Hello, let's continue our Sudoku adventure with Inquisition by Randall. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6, exactly once each. We also have these green lines in the grid. These are German whisper lines. Adjacent digits on the line have to have a difference of at least 3. So if this was a 2, we can't put a 1. That's a difference of 1. Definitely can't put a 2. That's a difference of 0. Also, it breaks Sudoku. Can't put a 3. That's a difference of 1. Can't put a 4. That's a difference of 2. Now, we could put a 5. Difference of 3 is at least 3. And also we can put a 6. Difference of 4 is at least 3. So next to the 2, we can put a 5 or a 6 is the conclusion. So that's how German whisper lines work. And that's true of every pair of digits along the line. So these two and these two, these two, these two, these two, these two. Sometimes German whisper lines are called fake lines because they don't actually need to be lines. They're just a relationship between cells that tend to be liney. Right? We could make this a dot between these two and a dot between these two, and it would work exactly the same way. All right. We also have quadruples in the grid. Those are these circles that are. Let's use this as a simple example. The circle touches up to 4 cells. If it's on the edge, it might not. All of these do touch 4 cells though. And what the digits in the circle must appear at least once each within the cells it touches. So there's a 4 in one of these 4 cells. Now this 1, 1 here, because the 1 is listed twice, it means we need 2 1s to appear somewhere in these 4 cells. So for each of the digits, it has to appear at least once each. And so each of these 1s tells us that we need at least 2 1s. We can't just put a single 1 and fulfill both clues. We have to put 2 1s. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so German whispers have a property that is quite interesting, and it's by design. By the digit picked changes by grid size so that this is always true, and it's that we alternate between low and high. So imagine this cell here was a 1, 2, or 3. We don't know which one it is, but we're going to call 1, 2, and 3 low. Let's say it was a low digit. Then the digit next to it on the German whisper line has to be high, has to be 4, 5, or 6, because we need a difference of at least 3. And from 1, 2, and 3, we're going to have to add at least 3. So if we add at least 3 to 1, we end up with at least 4. So we end up in the 4, 5, 6 range. And then from 4, 5, 6, we end up back down in the 1, 2, 3 range. So we don't know whether this is low or high, but we do know that they alternate. And so this has 3 greens and 2 purples on it. It goes green, purple, green, purple, green. We don't know if green is low or high, but we know purple is the other one. So we can kind of color to represent how they alternate. Now we know that what I did here is we know that there's exactly 3 lows and exactly 3 highs in every row, column, and box. So this box here just needs 1 more purple. It needs 3 of each. And so this is also a purple. Now we know that these aren't 6. Which could be, actually that's quite interesting. So because of this 3, 3 quad here. So the 3, 3 quad is telling us that we either have 3s like this or 3s like this. And so one consequence there is that it uses up the 3s for this column. So the 3 actually has to be in one of these two. And then the 2, 2 here uses up the 2s for these columns. So the 2 has to be down here. So if 2 is our low, then our high has to be 5 or 6. Because remember, 2 can't go with 4, it's too close. But it can't actually go with the 6 in this domino. This domino has a 2 in it. We don't know if it's the green or the purple, but it has a 2 in it. And it does not have a 6 in it. The 6 is over here for the box, or because of the quad, which affects the box. And so this is actually definitely a 2, 5 pair, and that means this is definitely not a 3, meaning the 3s go like this. The other thing I was going to point out is this couldn't have been a 3 because this couldn't be 6, but it being a 2, 5 pair is even more powerful. Now we know this is down to 1, 4, 6 now, and we can't put both the 4 and the 6 on here because they aren't far enough apart. They're 2 highs. And so that does mean we're using the 1, which means this can't be the 1, and the 1 is going to join the 4 or 6. So actually, I don't think we needed this 1 quad at all. This 3 is the low for this pair of digits here on the German whisper, and so it has to go a 6. That's a 3, 6 pair. And so now we know the 6 in this box goes here. And then this is a 1, 4 pair. Now we know the 6, placing the 6, actually placing the 3 told us these were low. So that's 2 and that's 1 and that's 4 and 5. But I didn't notice it because I was doing other things to follow up. All right, I got rid of the colors because I don't think we need them. But over here, we're doing 1, 2, 6. And so we know that we can't have two lows. And so the 6 ends up in one of these two. This isn't 6. And then down here, we're going to have 3, 4, 5. This can't be the 3 because the 3 has to be in this quad. All right, now we do need two 2s here. The 2 ends up here as a result. What else can I say? There's a 3 up here somewhere. Sometimes doing that's helpful. We already used up the 1s for these two columns. They're here or they're here. So these can't be 1. In fact, this is the only place for 1 in the box now. That place is 2 and 6. And now this is low, so this can't also be low. So it's 4 or 5. So this is our 3. Okay. This isn't a 2, so the 2s go like that. And that makes this low, making this high and this low. These can't be 6, placing the 6 in the column. 1, 4 is viable. Our final digit, we already have 1, 2, and 3. Our final digit is the 5, which makes this 1 and 4. We can place the 2 up here. So this is going to be 4, 6. We know the order. And this is 1, 3, 5. That can't be 1. That can't be 3. Is this the last thing to look at, maybe? Let's look at... let's finish this column. That's a 5. And then this pair is going to be 1 and 4. All right, I fulfilled the 3, 3, the 2, 2. The 1 is working. The 6 is good. The 3 is good. This is the other 2 for this 2, 2. And that makes a low here. So this has to be high, and it can't be 5, and it can't be 4. 4 is too close. So that's a 6. And now 6 can be next to 1 or 3, but this can't be 1 or 2. So this has to be 3. That's 5, 1, 3. Sorry, it could have been 1, 2, or 3, but I already had seen it couldn't be 1. I did not see it couldn't. Sorry, I'd already seen it could be 2. I did not see it could be 1. Anyway, that's 4 and 5. That's why I said it weird. I'm sorry. That's a 5. We're left with 1, 4 here. And it looks like we can't resolve this, but we have this 1, 1 here telling us we need 2 1s. So that's 1, 4, 1, and 4. Nice. Cool puzzle, Randall. Some clues might exist simply for symmetry. It looks like we have rotational symmetry, almost rotational symmetry on our clues. This 3, 3 and this 1, 1 aren't symmetric, but the 4 and the 6 are, the 1 and the 3. Anyway, cool. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.